We're going to see how each of the common symmetry operations affect a set of vectors that are along the coordinate axes. So I'll keep these color-coded. My z-axis here is going to be purple. My y-axis here is going to be red. And my x-axis here is going to be green. And let's start with the identity operator. The identity operator doesn't do anything to the axes, and so those are all left alone. So x is left alone, y is left alone, z is left totally alone. Okay, none of those are bothered, none of those are moved. And so x is left alone, y is left alone, z is left alone. We'll see as we go through, when something is unchanged, it gets a character of +1. So the overall character here is +3. We add up whatever numbers that we get here. Okay, boring so far. The next one we'll do C2, and we'll rotate around the z-axis. Okay, z is purple. Y is red, X is green. We're going to do a rotation around the z-axis. Well, anytime we do a symmetry operation around an axis, the axis that we're doing it around is left unchanged, so z still points up. X, which pointed out of the page, now points into the page. And y, which was pointing to the right, now points to the left. Well, let's see what happens to the character here. So z, we already know what to do. It's unchanged, so it gets +1. X, the green was pointing out, it's pointing in, so it's -1. And y was pointing to the right, now it's pointing to the left. It has a character of -1. So again, we just sum these up to get the value. So +1, -1, -1 gives me an overall character for that operation of -1. Next, let's look at a reflection. So let's do a sigma v. See which one would be the easiest to do. YZ. Okay, the YZ, that's the reflection plane that we're talking about. Again, they're all going to start the same. So reflection through the YZ plane. Well, that means X, which is out of that plane, gets reflected into the negative of itself. But the two vectors, the Y and the Z, that are in that plane are left unchanged. Okay, so let's see what that gives us for the overall character here again. So X was left alone, Y was left alone, Z was left alone, Y was left alone, X goes into the negative of itself, so +1, +1, -1 gives me an overall character of +1. This is going to be true for any reflection. So if I had chosen any of the three possible planes, XZ, XY, YZ, any of the three planes would have kept two of them unaffected and then would have affected the third one. The final common one that we will be talking about in this class is inversion. Do the inversion, everything goes to the opposite of what it was. So Z was pointing up, now it's pointing down. Y was pointing to the right, now it's pointing to the left. And X, which was pointing out, is now pointing in. But this one has a character of all of them have went into their negative, so negative, negative, negative. minus 1, minus 1, minus 1 gives me overall character of minus 3 for this. Okay, so we have our 4 main operations we'll use for this class. Identity, C2 about one of the axes, sigma, so a mirror plane in general, and inversion. And this is how their characters would be. So regardless of which point group we're talking about, if we see an inversion per atom, it's going to be a minus 3. If we see a mirror plane per atom, it's going to be a plus 1, C2 minus 1, and a C2, an E plus 3.